This might look like a little bit intimidating, but to reverse link it using recursion actually doesn't need that much of a code. What we really need to understand is just the fundamentals of a recursion here. So first of all, the base case. So the base case is when the function is reduced to something that it can't be reduced anymore, and we have to start really from there and then back to the function where the functions really was starting from. Um, in this case, if we start from 1, we then go to 2, and then we go to 3, and we find that we can't really go anywhere else other than figure out a solution here and then go backward. So we have to see 3 as the base case here, and when we regard the 3 as the base case, it means that we are actually seeing this 3 as a single node, and to do a reversion of the single node is just to keep it. So here it's easy that to reverse a base case is just to keep it. And then from here, when we want to go back to the next one, it's just to reverse this arrow to make 3 point to 2. And then all this becomes the second case, and we make it point to 1 again to reverse this arrow. And how are we going to implement it? Let's first try to code it out, and I'm going to explain it out while coding it. Um, so first of all, the base case. And we should always need to call the function because it is a recursion. And in this case, as we have seen, there are two things happening here. There is a head and there is a head.next. And we need to make head.next point to head. And we need to make head point to none. And what we are returning? We're returning the new head. And always need to remember in LeetCode, we need to examine the extreme case. And here, the extreme case is when there is no head. The head is none. And we need to rule it out. So now let's run it. Yeah, it's accepted. So let's talk about this code again to make sure that we really understand what is happening inside this recursion. So every recursion is happening in the stack, and every function is just using different memory pieces in this stack. And when the function is stopping here, the head and head.next is stored there as well. And it is there waiting for the function to really understand how to run it. And then what it is doing is just to run the following functions, and the new head that is here is just the returning of the it's just the returning values of the functions that has happened before. So here when one is coming into the stack, head equals to 1 and head.next equals to 2. But and by head here I mean the thing that is really called in this function. So it is head. So because head is 1 and head.next is not none, so it is not the base case yet. The the function doesn't know how to really do it, so it stops here and it comes to the next one. Head becomes head.next. So here head is 2 and head dot next is 3. And still, because head dot next is not none yet, it goes to the next part of the stack. Um, the same function again, instead that the head becomes 3 and head dot next is none. And because head.next is none here, we really know we actually know how to do this function. So here it goes to the base case, it returns head. So here the new head is 3, and by 3 I mean a node that is 3 and is pointing to a none. So after we know this function's returning value, we know this function's returning value because it is the same. And so new head is here, the new head is the same as this one. A 3 that is pointing to none. And here, because this function really works, what we really need to remember is that this function doesn't do again. This function was stopped, but it knows how to do it. How to do it is just to return the value from the previous one. So so this head and the head dot next is still 2 and 3. And what we are doing is actually we're doing all these three ones. And the head dot next now is 3, so head dot next is head means that we are reversing this arrow. And then head dot next is none means that the 2 is pointing to none. And now what is returned here is in this red part, the new head, which is 3 pointing to 2 and pointing to none. And since we have already know what is returned here, we know the returning value of this function, which is exactly what is returned here, the red part. And now the head is 1 and the head dot next is 2 because it's stored here. It was waiting for the returned value here. And now the head dot next is head means that 2 is pointing to 1, and head dot next is none means that 1 is pointing to none. And here the new head becomes 3, 2, 1, and none. So the new head that is returned is exactly the returned the reverse linked list. And the time complexity is O(n).